This is part 2 of the Unit 4 review explanation of problems. It is important that you have attempted the problems on your own before watching my explanation of these problems. So let's start with question number 12, a cube root function. So you're considering that function and describe the transformation that occurred to the parent function. Well, first we notice that there is a plus 5 on the inside where the parent function, that basic function, does not have that. So that is our h value. So our h is, we write down the opposite, so negative 5. When we had an h of negative 5, that made the graph move to the left. So we're going to move left 5 units. You can always check this in your graphing calculator. So hit the y equals button. If you want to type the parent function in, you could view that, but I'm just going to type in the function that we have here, h of x. So you'll go math, option 4, and we have x plus 5, and that is on inside the radical. Now if your plus 5 was outside the radical, make sure you arrow out and then do your plus a number or minus a number outside of the radical. It does matter. You've got to tell the calculator the function that you have. So it does match up. We can go second, no second. Just hit the graph button. Hopefully you know the parent function will go through the origin. And so here, 1, 2, 3, 4, 5 to the left, because the parent function is passing through the origin, that is exactly what we said it should do, is left 5 units, because we have that negative 5 as our h. So use that graphing calculator to give yourself a picture to see when you're answering these questions. Let's look now at question number 13. We have our function, it's the parent function. It's translated 5 units to the right and 5 units down. We're going to write a g of x function. So 5 units to the right is going to give us an h value. Remember that h value is what moves it left and right. We have a 5. Since it's going to the right, we're going to keep it positive because the right is positive to the left is negative. We're going to move 5 units down, so that's our k value. So again, we have our 5, and because we're going down, that k needs to be negative. If k was positive, it'd go up. If k was negative, it goes down. So we have 5 units down. So we're going to write our function g of x. So g of x, we don't have an a value. It's not reflecting anywhere. So we're going to just do our cube root of x minus h. Our h was positive, so we're going to write the opposite inside of our radical sign. So x minus h, since our h was positive, we're actually going to write minus. But for the k value, you write exactly what you see. So minus 5, and make sure that one is on the outside. So we're following the format for a cube root function. We're following the format cube root of x minus h. Our a value would have gone out front if we had a reflection, and then our plus k is on the outside. So if you want to jot that down, that's the format we're following to write in our cube root function. It went 5 units to the right, so we'll see that negative 5, and it went 5 units down, so we'll see this as our negative 5. Let's take a look now at number 14. Given the function, so we have that function, we're going to select the points that are on the graph of f of x. We're going to select all that apply, so that means there is going to be more than one correct answer choice. So we could do input output, so using our function f of negative 216, we're going to try and get the output of a 6. So we're going to do the cube root of negative 216, and then we're going to add 12 to that. Well, since we're going to the graphing calculator to type this in anyways, because we probably don't know what the cube root of negative 216 is. You might know, but math, option 4, negative 216, make sure you arrow out to do your plus 12. So since you're typing that in the calculator anyways, it'd almost be best just to go to the y equals menu. So I'll show you that as well. Our output value is a 6, so this is a point that would work. So let's look at the y equals menu. So we could type in that function. Now, when you type in the y equals menu, make sure you're telling the calculator x. Don't plug in the numbers for it, because when you go second table, it's already plugging in as x, that variable. The numbers vary, so it's already going to plug in the numbers that you're asked for. So in the y equals menu, just type in the function with the variable x. So math, option 4, type in that x, arrow out to say plus 12. Make sure that plus 12 is on the outside of the radical. When you go second table, you can scroll. So if we scroll to a positive 8, we do not see negative 10, so we're not going to pick that one. Now some of these numbers you might have to scroll for a while. So there's a couple different options to change your calculator settings. You can go second table set and just tell it where you want it to jump to. So if you want to jump to 27, you can tell it to start the table at 27. So second table, beside the 27 we do see 15, so we'll select that one. Or you could also go second table set, and instead of automatically generating, you could tell it you want to ask. So when you go second table, your table is actually going to be blank. So you're going to just type in 125. Once you ask for that number, it's going to give you the output. So we do not see that value. Let's try the negative 343, and we do see the output of a 5. Make sure that if you change your table set to ask, that you change it back to auto, or just do a calculator reset so that when you need the next problem, you have your full set of table values as you need it. Alright, so A, C, and E are the choices that will work. You can do an input-output to see if those ordered pairs work, or use the graphing calculator to help you view that in the table. So let's take a look at number 15. We're going to look at square root function. We're going to select the graph of this function f of x equals negative square root of x. So think about a lot like with quadratics. If we had the negative out front, it made it open down. So that is a reflection across the x-axis. So this negative out front will do a lot the same, reflecting it over the x-axis. We can also think when your negative is on the inside, you have to change your x values so that it can work in the square root function. So that means it's going to reflect over the y-axis. When it's on the outside, it's going to change and reflect over the x-axis. Or you can make all that thought process a lot easier on yourself and just use the graphing calculator. Hit that y equals button, type in negative square root of x, so make sure your function is exactly what you want it to be. Hit that graph button and just see the same picture that you should be selecting. So with that negative out front, it is going to make it reflect over the x-axis. The first answer choice A is the parent function, just plain old square root of x. Answer choice C is the one we're going to select because it makes it reflect over the x-axis. And that's exactly what our graphing calculator shows us as well. So use that to your advantage when you can. Question number 16. Let's write a square root function for the graph. So we know our parent function is just the square root of x. We now got to decide what's happened to this function. We're seeing that it's moved to the right. So 5, 6, 7 is where it's at. That's at 7. So it went right 7. Remember, when we move that left and right value, that gives us an h. So our h is 7. But when we actually write our function, so let's name it whatever you want. So g of x, or your favorite letter, h of x, or whatever, doesn't matter. You can just say y. So your function, whatever you want to call it, we are going to have a square root, because that's what this type of function is. We're going to say x. Instead of writing plus 7, we have to write minus 7, because remember, with that h, we want the opposite. This graph is not moving up or down, it just went to the right. So that is our function for the square root graph. Number 17, we're going to determine the domain for the function, and that is our parent function. If the function is shifted left, how will that affect the domain of the resulting function? So let's first talk about the domain of just our parent function. So if you have to, sketch a little picture or use your graphing calculator to view the graph. So if we have a basic just square root function, f of x equals the square root of x, so that is our parent function. This domain is all the x's such that x is greater than or equal to 0. Here is our 0. That's where the graph starts, and then it turns off, and everything greater than on this x-axis is what this graph will touch. So if we translate our function, let's go ahead and write that new function. So it's going to be the square root. Since we're going left 8, our h value will be negative, but we're going to write x minus a negative. So that's really, we're going to write plus h. Or sorry, plus 8. So the h value, we went left, so that's a negative 8. When we put it in our function, we know already to make it opposite. So we're going to say plus 8. So that's our new function. Now we got to decide what is the domain of that new function. So draw yourself a picture if you need. Since we're going left 8, we're out here somewhere, 8 units. It's now going to look like this. So that's our new function, and we've called it g of x. So because we went left 8, our domain is not going to stay the same as our original function. It is going to change because it shifted to the left. It's shifting down that x-axis. It's going to actually start at 8, but it still is greater than. All these numbers are going to be greater than that. And actually, because it shifted left, that is a negative 8. I almost messed that up. Which was our h value? Negative 8. So we're going to say that our domain of the new function is being greater than or equal to negative 8. By shifting that graph to the left, it does change our domain, and it now makes it greater than or equal to negative 8. Alright, let's talk about question number 18, exponential functions. We're going to select the function that shows a shrink of an exponential growth function. So first of all, let's talk about our a and our b values when we're talking about exponential functions. Remember, they are in the form a, b raised to the x. So that a value is either going to cause a stretch or a shrink, and then the b value is going to be what causes a growth or decay. So because we are wanting a shrink, we are going to need to know that our a value is between 0 and 1. So you can write that 0 is less than a is less than 1. So really just knowing it's between 0 and 1, we're looking at those fractional or decimal numbers between 0 and 1. So look down through here, and our a value, that first number, option A and option D give us those values that's going to result in a shrink. If it was a stretch, our a value would be greater than 1. Well, that's option B and C. We don't want those. We want a shrink. For our exponential growth or decay, we're going to look at the b value. In order to be a growth, which is what this problem's asking for, in order to be a growth, we need our b value to be greater than 1 to make that exponentially grow. So we narrowed down already to a and d. Our b value here is a fraction that's less than 1, so we're not going to pick that answer choice A. We are going to pick answer choice D, because that 4 is going to be greater than 1. So that shows us the shrink and the growth that this question is asking about. If we were looking for a decay, that's going to be a number that's going to be, again, just like the shrink. To cause that decay, it needs to be between 0 and 1. Let's look now at question 19. A used truck is purchased, and the price of the truck is determined by the function. So we have that function given. We're going to determine whether the function is a exponential growth or decay, as well as what is the initial value. What was that starting value of the truck when it was purchased used? Well, going back to growth or decay, we're going to look at our B value. So here, our B value is 0.88. So because that is between 0 and 1, it's less than 1 but greater than 0, so we're going to keep in those fractional or decimal area, then this will be a decay. The initial value is the same as our A value. So this A value is our initial value. So that 4,000. They paid $4,000 initially for that truck. Now you could also find the initial value by plugging in 0. So if you plug in 0, anything to the 0 power equals 1. So when you multiply 4,000 times 1, it does give us the same value. So it's going to be your A value for that initial value. Question number 20. A bank account starts with $10. Every month, the amount of money in the account is tripled. Use the exponential growth function, and there it's given, where X represents the number of months and Y represents the amount of money. How much money will be in the account at the end of 6 months? So because the X value, X represents the number of months, we can plug in this 6 into our function and it will tell us the amount of money. So let's plug that in. Y equals 3 times 10 raised to the 6. Now you could work this out with order of operations. Of course, 10 to the 6 and then multiply that by 3. But we're also going to use this graphing calculator. So 3 times 10 raised to the 6th power. There's 1, 2, 3, 4, 5, 6 zeros. So that would be the amount of money at the end of 6 months. So that's a pretty good deal if you're just starting with $10 and you can find an account that will triple it. So after 6 months, that's quite a bit of money. So use this blank space on your review to jot down anything else that you know you need to study, anything particular that you know you've been struggling with, or just lessons that you need to revisit. So use this blank space to make notes of other things you need to be especially careful of.